Hello everybody, in this video I will discuss common fractions, more specifically squares, cubes and square roots and cube roots. Before I start, let me quickly remind you of this law that you have in exponents, where when I give you a to the power of m raised to the power of n with a bracket there, then it means you're going to multiply the exponents. So if I give you x squared over y to the 3 raised to the power of 4, then you can take this 4 and distribute it to the x and the y's exponent and multiply. Therefore, it becomes x to the 2 times 4 over y to the 3 times 4 is x to the 8 divide y to the 12. Now the sum, simplify. 3a over 4 squared times 2 over 3a to the 4 squared. So what you're going to do is you're going to take this exponent and you're going to give it to everybody. So it becomes 3 squared a squared over 4 squared times 2 squared over 3 squared a to the 4 times 2. Be careful there. And then in the next step, 3 squared is 9a squared over 4 squared is 16 times 2 squared is 4 over 3 squared is 9, and then on a, it's a to the 4 times 2, which is a to the 8. Now this brings me to the fractions, where you can now say 9 goes in itself once, 9 goes in itself once, 4 goes in itself once, 4 goes into 16 4 times. And then I'm left on the numerator with a squared over and the denominator 4a to the 8. And then when you divide exponents on a squared and a to the 8, you subtract them. Therefore, you're left with 1 over 4a to the 6. Let's simplify. Inside a bracket, x plus 3x over 2 raised to the power of 3. So I'm going to do the bracket first, the inside of the bracket. Remember, if there's nothing, then x is over 1. Now I find x over 1 plus 3x over 2, so I'm going to add, so I need an LCD, and the LCD is 2. So the second term is already over the LCD, it's this one, where I'm going to multiply the denominator and the numerator by 2 to get it over LCD. Therefore, it's 2x over 2 plus 3x over 2. So now they are on the same denominator, and I can say 2x plus 3x over 2 becomes 5x over 2 raised to the power of 3. And now I can say 3 will be given to 5, to x, and to 2. And therefore I end with 5 to the 3, x to the 3 over 2 to the 3. And 5 to the 3 is 125, x to the 3 and 2 to the 3 is 8. And then that is an improper fraction, and I can write it as a mixed number. And the mixed number will be 15 and 5 over 8 x to the 3. Simplify, and I give you 5x squared divide 50x to the 4. So first of all, I'm going to deal with the square, and I'm going to raise that one, the 5 to the 2 and the x squared. And remember, now you're going to say it's 2 times 2. Still divide 50x to the 4. 5 squared is 25, and then x to the 2 times 2 is 4. Now, because it's division, I want to change this into a times, and I'm going to tip this one around. I'm going to swap it around. So you write it over that invisible 1. So it becomes 25x to the 4 times 1 over 50x to the 4. And then this 25x to the 4 is also over invisible 1. And now I can cancel out. I can say x to the 4 and x to the 4 can cancel. 25 goes in itself once, 25 goes into 50 twice. And then the answer on the numerator is 1 and the denominator 2. So the answer is a half. Now let's look at the roots. there's a rule that says when everything is over this one root and its division, then you can write it as root x to the a divided by root x to the b. So when I give you a sum, simplify the whole root over 25 over 81, you can split it into root 25 over root 81, which is 5 over 9. Simplify root 16 over x squared. So you take the root and you distribute it to the numerator as well as the denominator, and you write it as root 16 over root x squared, and then it's 4 over x. This one, root 4a to the 6 over 9b to the 8. So what you do is you distribute the root to 4a to the 6 over root 9b to the 8, and then it's the square root of 4 is 2, and then what happened on a is, since there is an invisible 2 there, you are dividing the exponents by 2. That's why it becomes 2a to the 3 over 3a to the 4, because a divided by 2 is 4. And then this one you can take further, since it's a cubed on top and a to the 4 at the bottom, you subtract exponents and the answer 2 over 3a. Simplify root 16 plus 9. Now I added the sum because I want to show you that root 16 plus 9 is definitely not root 16 plus root 9. You cannot split it when there's plus and minus. It only works with division. So just to show you that sum, root 16 plus 9, you will rather add the two terms together and you end with a root 25, which is 5. Then, if I give you this, root 2 over 25 plus 7 over 25, now, because of the plus, you cannot split the 2 into two individual roots. What you do is you first add the two fractions. So that will become 2 plus 7 is 9 over 25. Now that it's one single term, you can split it into root 9 over root 25, which is 3 over 5. Then, if I give you this one, simplify root 4a over 5 squared. Then what you do is you're first going to distribute this 2 into everything. So it becomes 4 squared a squared over 5 squared, still under one root. And then 4 squared is 16a squared over 25. Now you split it into root 16a squared over root 25. And then the square root of 16a squared is 4a over 5. When we deal with cube roots, it works exactly the same way as you would with a square root, where you can split them. So if I give you the cube root of 8 over 27, you simply split into cube root of 8 over cube root of 27, which is 2 over 3. The cube root of a to the 3 over 125, you split them. Cube root of a to the 3 over the cube root of 125 is a over 5. And then this one looks very complicated, but it's really not that bad. The cube root of 64 x to the 9 over y to the 3. So you split it up into cube root 64 x to the 9 over cube root y to the 3. And now I just want to show you with cube roots on the exponents on the variables, you will divide by a 3 and divide by a 3. Therefore, it becomes 4x to the 3 over y. Simplify the cube root of 1 over 125 plus 2 over 3. So you will split it into cube root of 1 over cube root 125. And then the cube root of 1 is 1 over 5 plus 2 over 3. And now it's a normal addition of fractions. So you will find LCD, which is going to be 15. And then you're going to say, this first term I'm going to multiply by 3 over 3. And the next one I'm going to multiply by 5 over 5. Therefore, it becomes 3 over 15 plus 10 over 15, which is 13 over 15. In the next video, I will discuss percentages and fractions. Click on the video in the left-hand corner to take you straight to the next video.